Alright, 6.2, use proportions to solve geometry problems. I think most of you guys already kind of know what a scale drawing is. A scale drawing is a drawing that is the same shape as the object it represents. Maps are good examples of scale drawings, or if you guys have ever seen a diagram of a house or a room that's drawn quote-unquote to scale, those are scale drawings. We'll do some examples of what these are. Alright, the scale is a ratio that describes how the dimensions in the drawing are related to the actual dimensions of the object. So if you have a map where 1 mile equals 1 inch, then every inch on that particular map is equivalent to a mile in real life. And there's all kinds of different scales you can use. Let's go over some properties of proportions. Reciprocal property. Remember, reciprocal means when you flip something over, if A over B equals C over D, then if you flip this over, B over A equals D over C. Also, if A over B equals C over D, then A over C equals B over D. So, you can flip a proportion. You can also go across. And if A over B equals C over D, then A plus B over B equals C plus D over D. Okay? Let's go on to page 2. In the diagram, AC over DF equals BC over EF. Now, if that's the case, then 12 over 18 equals 9 over x. And now they don't actually ask us to solve for x, they just want us to write 4 true proportions. Here's one. If we wanted, we could flip these over. Get 18 over 12 equals x over 9. Or we could go across. So 12 over 9 equals 18 over x. Or you could do the thing where you add them. 12 plus 18 over 18 equals 9 plus x over x. And you could rewrite this. 12 plus 18 is 30. 30 over 18 equals 9 plus x over x. And you could simplify this if you wanted to. Alright, in the diagram, JL over LH equals JK over KH. So I'm going to use one of the properties of proportions, the one where I add JL plus LH, the top plus the bottom, and put it over the bottom. This equals JK plus KG over KG. I do this because I don't know what JL is. I know what JH is. Okay? And JL plus LH, that's JH. Let me write that in here. JK plus KG is JG. Okay? I know that JH is X. And LH is 2. JK plus KG, that's 15 plus 5, which is 20. And KG is 5. So from here, I'm going to cross multiply. I got 5x equals 40. If I divide both sides by 5, x equals 8. So JH equals 8. JL equals 8 minus 2, which is 6, because if this whole thing is 8 and this piece is 2, then this piece has to be 6 to make the whole thing 8. Alright, I'll let you guys do the checkpoint. Let's go on to page 3. The length of the key in the scale drawing is 7 centimeters. Okay, so I'm going to label that. Oop. Straight enough, I guess. 7 centimeters. The length of the actual key is 4 centimeters. What is the scale of the drawing? Okay, so if this whole thing is 7, the length of the key is 4, we're going to have a ratio of 7 centimeters to 4 centimeters. And I realize I skipped these 2 blanks. To find the scale, write the ratio of the length in the drawing to an actual length, which is what I just did. Then rewrite the ratio so the denominator is 1. So what I'm going to do here is I'm going to divide top and bottom by 4. The centimeters are going to cancel out. If I divide top and bottom by 4, I get 1.75 over 1. Okay? Which is just 1.75. So the scale of the drawing is 1.75 centimeters to 1 centimeter. Okay. Alright, checkpoint, I'll let you guys do that. The scale of the map at the right is 1 inch to 8 miles. Find the distance from Westbrook to Cooley. Now, obviously you guys, some of you guys might have a ruler. If not, don't worry about it. I'm just going to tell you that the distance from Westbrook to Cooley on the map is about 1.25 inches. Okay, let x be the actual distance in miles. So, 1.25 inches is something, some value in miles. And this is the scale, 1 inch over 8 miles. Let's cross multiply. X times 1 is just x. 1.25 times 8. Oops. I'll write that in here. Also notice, oh, never mind. Looks like we have 10. So the actual distance from Westbrook to Cooley is about 10 miles. Okay, let's go on to page 4. Okay, scale model. You buy a 3D scale model of the Sun Sphere in Knoxville, Tennessee. The actual building is 266 feet tall, your model is 20 inches tall, and the diameter of the dome on your scale model is about 5.6 inches. What is the diameter of the actual dome? Okay, let's do part A first. We know that if your model is 20 inches and the actual building is 266 feet, this is the scale. Now, the diameter on your model is 5.6 inches. This is what we're trying to find. So let's cross multiply. I've got 20x equals 266 times 5.6. Let's do this. I'm sorry, 1,489.6. And then we can divide by 20. $74.48. So the diameter of the actual dome is about 74.48 feet. Now, how many times as tall as your model is the actual building? So, to simplify a ratio with unlike units, you need to multiply by a conversion factor. We know that the ratio is 266 feet over 20 inches. Okay, I'm going to rewrite that. And hopefully you guys know that there are 12 inches in 1 foot. I'm doing this so that the units all cancel out. Okay, 266 times 12. It's going to give me 3192 divided by 20. 159.6. So the actual building is 159.6 times as tall as the model. Alright, I will let you guys do the checkpoint, and that's all for today.